Now let's continue with our code. So you can see we imported the scikit-learn and basically we created our own data set in the previous lecture. We saw the data set, we saw this describe and info method. Let's continue with our code. Now in this lecture we are going to do some visualization tasks. So we are going to count how much value are there on each of the classes. So here this is the code in order to plot that histogram for us. So this is a kind of a verbose code. If you want to make your own color and font size and so on, then you can just grab this code and just change it. But now you can see the main important part of this histogram. In order to visualize, just remember this code. In order to visualize, this is a very important technique. Now seeing this data, what you can see is imbalance in the data. So what I really mean by that is, let's see. There are 3 clusters. We have already seen this before. We will be making 3 clusters because the number of classes while making the data was 3. So first class is 0 class, second class is 1 class, and third class is 2 class. Now you can see for the first 0 class, the number of data is 100. So that means there will be this dot, these datas will be, the amount of data will be there 100. So there will be 100 data over here. Similarly, for the first cluster, there are 150 data, which is 50 data more than this 0 class. And similarly, in the 2, there will be 250 data. 250 data will be there. So that means 100 more than that is first 1 class, 1 cluster, and 150 more than this 0 class. So that means there is imbalance. So balance means whenever, if I say the balance should be something like this. If you remove this part, and if you grow the data of this 0 class, then this will be the balanced data. If you remove this entire part, then that would have been the balanced data. But you can clearly see it is the smaller, it is a little bit bigger, but smaller than the second this cluster, and this is the huge cluster. So that means there is an imbalance of data. Now whenever you imbalance data is trained, our model can be biased toward this class, which is 2 class. So our model can be biased, and whenever model gets biased, if you want to predict some data point onto this cluster, it is a high chance that it is going to predict in the class 2, because there is a variance or there is a low variance on it. So that is the reason we can see that this model might not be accurate. So what we need to do is, first of all, let's visualize a little bit. You can also see the outcome of having 0 is 101. So you can see 101 data are like 0 cluster. In the 0 cluster, 149 data are in 1 cluster, and 250 data are on second cluster. You can use this shape method to check the shape, and you can check this data. This way you can check whether the outcome is 0. So you grab it. So using this code, what you do is you grab those who has the low outcome, which is 0 outcome. So 0 outcome is over here. So similarly, medium outcome and high outcome. High outcome here is having 2, having the cluster at 2. So this way you can check your data. Similarly, you can use this value count if you want to check in which cluster there are how many datas. So in the zeros cluster, obviously we have plotted also. So you can also plot if you want, just using the statistical measure. You can also use this way. So it's up to you. Either you can visualize it or you can use this method in order to check, in order to count, and so on. Now you can also visualize using scatter plot. We are going to use the Seaborn library. So Seaborn library is imported at the beginning. So we are going to plot each of these features among other. So we are going to grab feature 1 and grab feature 2, and we are going to plot feature 1 against feature 2. So feature 1 will be at the x-axis and feature 2 will be at the y-axis, and we are going to plot. And here the data that goes in the 0 cluster is over here, in the 1 cluster is over here, and in 2 cluster is over here. So you can see the variety of data. It is not composed as a cluster over here. Similarly, if you go on the feature 1 is just plotted against feature 3, then you can see the cluster has been made over here, right here. So this cross is for the 1 cluster. So 1 cluster has been created properly over here. So similarly, you can visualize for each of these cluster and see what insights can you get using this visualization technique. Now you can see, you can also plot the histogram. This is the histogram for feature 1. This is the histogram for feature 2, histogram for the feature 3 and feature 4. You can also see this distribution is a standard distribution and so on. Now, the next thing is you can clearly see by seeing this data, there is an imbalance in our data set. There is obviously imbalance in data set. The data at this basically in the cluster 2 is higher than the 0 and 1, and in the 0 it is a low outcome cluster. So that means whenever we predict, we use this data in order to make our model can be biased towards cluster 2, and anything that is unseen by the model can go to the cluster 2. So there might be the biasness. So what we can do is we need to do sampling process. So what is a sampling? Sampling is a process in order to make your data balanced. So there are two ways, undersampling and oversampling. So undersampling means you are basically just removing these many data from these two. So you remove this part of data and you remove these 3 block of data from here. So this is undersampling. You just undersampling to the minimum outcome of your data set. This is undersampling. What is oversampling? So oversampling is you are increasing your data. So oversampling is you are increasing your data to make fit to the highest, that is highest cluster or highest outcome. So this is oversampling, and if you reduce data, that is oversampling. And here we are going to use, that is, you can see we are going to use something that is called SMART. So let's see here. So SMART is an oversampling method. So we are not doing undersampling, because undersampling can be done using random process, which is a random. You can use Python random library in order to randomly remove some of the data set. But SMART can be used in order to do the oversampling process. So what is oversampling? You are increasing the data to make the balance in the data set. You are increasing the data from the minor classes instead of creating sample. So that means oversampling method, SMART is oversampling method which creates synthetic example from minor classes instead of creating samples. The algorithm selects 2 or more similar instances and creates 1 attribute instance at a time by random amount within the difference to the neighboring distance. So what does this means is basically, if we have this cluster, let's say this cluster, so if we have this 0 cluster, then it is going to just create the data based on its neighboring data. So it is just taking the reference from the neighborhood data and it is going to increase the data at this place. So that is the SMART process. Now we can do using this library from this imbalance learn, IMB learn. So it is available in the Anaconda, but if you want to just import it, imbalance learn, source online imbalance learn, pip install imbalance learn will be enough. So this way you can oversample your data. After oversampling, you can clearly see we have now, that is data in the 0 class we have 250 data, in the 1 class we have 250 data, and 2 class will also have 250 data. So that means the data from the 0 class and the 1 class has been increased. So this is a oversampling process. We did oversampling. Now the data is balanced. There is no, that is minor classes over here. All the classes has equal number of data. Now next thing is to use scikit-learn, and we are going to use scikit-learn, that is to parse the data into training and testing split. Now I have already told you about train test split. This is going to divide our data in the training set and testing set so that our model will be trained on the training set, and in order to evaluate our model we can use the testing set. So in this data you can clearly see test size is given 0.2 and the random state, this value, the random state value should be same as before when we just created the data for us. So if you remember, whenever we create the data, this was the same value. So this random state should match with the random state of this training and testing split, which is right here, this value. If you give 2 here, so 2 should be over there also. So this is a memory location from where you want to just split your data set. Now after just doing that, you can see we have training data, that is 600 data has been used in a training and 150 will be used for the testing, because we have told here 20% of entire data set. So how many data we have? So we have like 250 data. So in the 250 data, or basically we have 500 data, not the 250. So it should have somewhere. So how many data we have? So those data will be divided into, so 0.2 means 20% of entire data set will be used for testing, which means 150 data, and remaining will be used for the training. Now what we need to know is about the classification tasks. So what is a classification task basically? So above generated random data set can belong to the classification problem because we have different labels. Labels means cluster. We have 0, 1 and 2, which is known as supervised machine learning, and we have already discussed about this classification problem. So classification problem is a supervised machine learning approach in which the computer are trained to learn from the data input given to it and use the algorithm to classify new observation. So we use the data that we already know in order to create a model, and after the model is built, we use that same algorithm to classify new observation. So that is a classification problem. For example, you can see classification is used to search the answer of the question like which are the listed below. So let's see, does this picture represent the letter A, B, C, D or what? So that can be used as a classification. Is this picture represent a truck or a car or a bus? So we are classifying among the classes. So that is a classification. So classification means it is a problem of identifying the classes or category of an object. So that is a classification problem. We have many algorithm which is right here. Nearest neighbor algorithm, artificial neural network, support vector machine and decision tree. So decision tree has been already defined in the previous course. If you have any confusion regarding it, you can just check the previous course that we have already been just shown, and that will be also available on the link will be also available, and that is important lecture also if you want to begin in the machine learning and AI that is area. So this is all about our several methods that is used for the classification, but now we are going to use this artificial neural network which is right here. So let's use artificial neural network. So this lecture, this course was entire about artificial neural network. You can use this file is to just sum up what is the neuron, what it does, what is the input, what is the net input, what is the activation function, and what is the application of MLP, and so on. You can use it. Now let's talk about the code. So this line of a code is going to implement the artificial neural network for us. So let's see what we have done here. So from the scikit-learn, we have this neural network which imports the MLP classifier, and after that we just use this matrix in order to evaluate the model. After creating the model, we are going to use this matrix, so we imported here only. So after that we are going to instantiate the MLP classifier. So now in the MLP classifier there are several things that is written inside this. So this MLP classifier is an instance of an artificial neural network which refers to multi-layer perceptron classifier. So now here you can see hidden layer sizes. So what is a hidden layer sizes, which is also given right here? This is the first parameter used in a model which allows to set a number of layer and a number of node in our neural network. So you can see that hidden layer size is 300. So we have given 300, 1. So which means how many rows should be there? So how many rows? There should be 300. So the first here means how many neurons should be, and second, after the comma there should be how many layer. So in our case we have given nothing, that means default. So we will have only one layer with 300 neurons. We will have that size. So hidden layer size means how many hidden layer. If I do something like 300, 2, then what happens is there will be 300. Let's see here, 300, that is one layer, and again 300 another layer. So this way there will be distribution among these clusters, among these hidden layer. So we want only one hidden layer, so that is the reason we give 300 units of neuron and only one hidden layer. Similarly, activation, this is a rectified linear unit. You must have guessed now why we use the activation. So activation is to transform the activation or transform the input into the output. So ReLU is used. So ReLU is a rectified linear unit which expression is max of 0, x, and this means that it is going to allow all the positive value from the neuron and it is going to output that, and it is a non-linear function. It is an activation function. So it is an activation function that will be applied in order to get the output from the input. So verbose 1, what is a verbose 1? So verbose, if you make verbose equal 1, then this information, like see here, at this iteration the loss was this, and iteration the loss was this, will be available for you if you make the verbose equal 1. If you make verbose equal 0, then this information will not be available. Similarly, the solver, we have already discussed about this. Solver is a ADAM. So ADAM is a optimizer. If you remember, what does optimizer do? So in the case of neural network, we normally just implement stochastic gradient descent. If you remember, the stochastic gradient descent was what we use instead of our formal gradient descent. We don't use gradient descent because the data will be huge in the case of neural network. Obviously, in this simple program, we don't have huge data. Gradient descent would be enough. But when we just learn more about classifying the pictures and so on in the upcoming courses, obviously, then stochastic gradient descent will be very useful. And whenever the stochastic gradient descent will be used, what happens is, if you remember, this would be our main goal in order to reach the global optimum. So our main goal is to reach this point where we have the minimum error. So this is our main goal. So whenever we reach to this point, if you use stochastic gradient descent, then the gradient would move inconsistently. So this would be the position of the gradient. So this way, you can clearly see it would take much more time than the gradient descent in order to converge. So stochastic gradient descent takes little bit more time than the gradient descent. So that was the reason we use ADAM optimizer. So what does ADAM do? ADAM will smooth this curve. So ADAM will smooth this curve so that the gradient would converge effectively and faster. So for the fast processing, fast convergence, we use this ADAM optimizer. And similarly, we have this batch size that is related to stochastic gradient descent, how we calculate the loss and everything. The learning rate is a constant here. So constant means here learning rate initializer here. So constant means we are going to use this learning rate for our entire program, which is 0.001. So constant means this. We are going to experiment with this different attribute in the next lecture, in the next coding session. But now you can see this learning rate constant means we are going to use this value, which is 0.001 for our entire machine learning project. And similarly, we have iteration. So we have 1000 iteration. So this activation like back propagation and so on will be run for 1000 times. And we fit this model, and fitting means we give the training data in order to fit the model using this MLP classifier. So you can clearly see if you only create the object here, it is not going to work. You have to call some function in order to work with it. So we make the object over here and we call the fit method on that object and we give the training data. And after giving the training data, you can clearly see we run till our this 508 iteration, you can clearly see, and after that you can see the loss has been 0.06. So we have minimum loss, and it also told that training loss did not improve more than tolerance this. So that means the tolerance was this point. So stopping criterion was this point. So that means the loss was this position, the minimum loss, the point where the convergence was beginning to happen is this point. So that means we predict now. We predict using this Y prediction, and now next thing is we need to evaluate our model. That is important part. Now, how to do the evaluation of the model will be talked in the next lecture. See you in the next one.